All right, here we go. Unit 5, Lesson 10. You take a quiz, little break, and then you jump into 10.1 on page 273. Okay, here we go. So the images show the same number of coins arranged in different ways. So what I did in class is I brought some quarters in. For the display. So right here we got 20 quarters. And right here we got 20 quarters. So as I taught this lesson, we started creating these stacks. I hope you can see right here, but we've got an upright stack and a tilted or slanted stack. So the first question asks you, how are the two coin stacks different from each other? Well, this one is more upright. So it's like straight up and down. This one is tilted. Or slanted. Does either stack of coins resemble a geometric solid? If so, which stack and what solid? So, it does. So it's kind of like that shape. So yes. It resembles a cylinder. This one right here is called an upright cylinder. Now instead of tilted, we're going to name this one. This is what's called an oblique. Cylinder. So tilted, oblique. Also, this muscle right here is your oblique muscle. So another use of the word oblique. Number 3, how do the heights of the two stacks compare? Well, each one is 20 quarters, so if you look really closely at this quarter, right here, Bessie Coleman, look at that. Anyway, if you look really closely at this quarter, it has a little bit of depth to it, of course. But since the stacks are both 20 quarters, each stack is going to be 20 times whatever this is. Let's get a little measurement here. A quarter is about a 1/16 of an inch. So whether or not you tilt it or it's straight up and down, each stack's going to have the same height. So if each one is 1/16 of an inch, 20/16, so that's 1 1/4. So 1.25 inches. So each one of these is going to have the same height. So you're just going to say the same height. Now, how do the volumes of the two stacks compare? So to get the volume of a cylinder, you need the area of the base. So you need the area of the base times the height. There's the height. So the volume of a cylinder, area of the base, that's a circle. So you go pi r squared. That's the area formula for a circle. And then you just multiply it times the height. Now, in these stacks of quarters, the area of each cross section is a quarter. So the area of all the cross sections, we're talking about the horizontal cross sections, is going to be like the face of the quarter. I believe that's George Washington. We should know that. Anyway, the area of the cross sections is going to be the area of this circle, right? So every single cross section has the same area. The height we already talked about, same height. So there and there. That and that are the same because they're both 20 quarters. We already said it was 1.25 inches. So, if the height's the same, and the area of all the cross sections is the same, then the volume's the same. So the volume will be the same because areas of the cross sections are the same, and the heights are the same. So if all the areas of the cross sections are the same and the height's the same, then the volume's the same. This is known as Cavalieri's principle. I like to try to draw the Cavaliers logo with the basketball. Not my greatest attempt, but Cavalieri's principle, you can represent it by the two stacks of quarters. It comes up again in calculus. So Cavalieri's will return later in a couple of years in your calculus classes. But Cavalieri's principle states that if all the areas of the cross sections are the same and the heights of the solid are the same, then the volume's the same. Good stuff. All right. Next one. Here we go. So read the question while I erase. Okay, here we go. There's one thing I want you to start doing every time you read the directions. It's called circle, star, underline, highlight. So you basically like circle, star, underline, highlight the most important information in the question. So 10.2, rectangular prism shifted. We're going to use stacks of Uno decks for this one. So the image shows two rectangular prisms. The bases of the prisms are congruent. So you're going to see they're both Uno cards. Each base has area B square units. So B is represented by length times width. And the prisms are the same height. So what I did for this one, everybody loves Uno. I created the same number of cards in each stack. So we got the same number of cards in each stack. So that represents the same height. Unless, of course, you bend the cards. Just kidding. So a plane intersects the two prisms parallel to their bases. So a plane, giant playing card, is a good representation. It does actually have some thickness to it, but we're going to call it a two-dimensional plane, P-L-A-N-E. So it intersects these two prisms parallel to their bases, creating cross sections. So sketch the two cross sections. How do their shapes and areas compare to each other? The big thing I need to do is with one of these Uno stacks, I need to tilt it a little bit. So that's what we're going to do. We're going to tilt this stack like so. Okay? Now, we're taking this plane and basically like doing a horizontal cut of each of these stacks. And then remember, like with the Play-Doh, you pull it apart and look at what this shape is. So if I cut this right down the middle, the cross section is going to be an Uno card for that one. Cross section again, an Uno card. So what am I going to draw? Well, you want to draw the cross section, which is one of these cards, right? So here we go. All right, here's one. That was an awful 9. Cool. So that's for this one. This one I pulled off of the second deck. So here we go. This is for this one here. So to sketch the two cross sections. So you don't have to be perfect or that meticulous, but Uno cards for the cross sections. So how do their shapes and areas compare to each other? Well, they're both going to have the same length and width. So both same length and width. In fact, we could just measure it real quick. So the length of an Uno card is, it's looking like 8.65 centimeters and 5.5 for the width. Let me try inches. Usually they're like whole numbers. No, actually they're not. Okay. So yeah, they both have the same length and width. Therefore,
good morning, Pumas. It is Wednesday, March 6th. This is Ms. Harper Cotton with your morning announcements and phone trivia. Today you have even blocks 2, 4, and 6. Have a positive start by arriving on time to class as your passing periods are 5 minutes.
I'm going to talk through this. So,
Club sports general announcement.
if we move the plane up or down, so up or down, how would the shape or area of the cross sections change? Well, if I just went right here, as opposed to right in the middle.
Athletes, this is a reminder, please turn in those uniforms from soccer and basketball. They are due. All college bonding days and college tour permission slips are due at the end of the day today. No phone calls or field trip permission slips will be accepted.
How do the volumes of the two prisms compare? Explain your reasoning.
Slips are due at the end of the day. 11th grade students, check your email for STEM-focused tutorial space survey. We need your voice and survey completion to make this happen. Today will be the last call for participants, as we can only make this happen with students who are committed to joining. If you are a 10th grader, please see Mr. Moreno today with your interest. Teachers, thank you for your support during LPAC testing. We have completed the group testing and will continue to work with students to complete the speaking sections. Yearbook committee, meet in the library during lunch. Now for today's phone trivia. Please wait until I read the question to call extension 410 with your answer. The 5th caller will have the chance to win the Golden Puma. Hopefully they can keep it because there will be an opportunity to steal. Question. This novel was written in 1989 by Amy Tan. It focuses on 4 Chinese immigrant families in San Francisco who start a well-known club where people can play the Chinese game of mahjong for money while feasting on a variety of food.
I don't know.
What is the name of this novel?
Okay, equal volumes. So on this question, you got to compare these, see if they have the same volume. So the answer is either same or different. So for this, base equals 12. Base equals 12. Height equals 6. Height equals 6.
Congratulations to Ms. Norman's class. The answer was the Joy Luck.
Oh, I knew it.
And the question was, mahjong, a game of skill and luck, is played by how many people?
Should have known that.
Writing grade titles. Their answer was 2 to 4. Have a great day. on purpose.
Have a great day on purpose. What that means to me is like you're in control of your happiness. So decide that you're going to have a good day, and then you can have a good day. All right, so base, same base, 12, height's the same. I know from Cavalieri's that even if I tilted this thing, if the height and the base are the same, we are good. So these are the same. Okay, number 2. Well, I know the base is going to be the same because the radius is given to you here, and it's 3. However, the height of this is 7, and the height of this is 10. Remember, in our quarter stacks, just because we tilted it, the height stayed as 10. So because the height is different, these two are going to be different. So same for number 1, different for number 2. All right, next one. Okay, similar problem, base, radius 3. So you know these two circles at the bottom are going to have the same areas. Height is both 5. So because the heights are the same, and we remembered from Cavalieri's that even if you tilt it, as long as the height and the areas of the base are the same, volume will be the same. Okay, this one's a little tricky, number 4. You have right here a triangular prism. This is 5, 3, and 4. And then right here is a rectangular prism. So, for prisms, you need the volume formula is the area of the base. So base, area, times your height. So let's chip away at this. The area of the base on this one is this triangle area. If you look really closely, you'll see a right angle there, too. So there's a right angle there. So we got to figure out the area of that triangle. So the triangle has dimensions 3 and 4. So what's the area of this? Then we got to multiply that by the height. So 3, 4. The area equals 1/2 BH. This is a triangle area formula. Base is 3, height is 4. 3 times 4 is 12. Half of it is 6. So the area of this is 6. And then you got to multiply it by the height, which is 5. So you're going to get 30 cubic units for this one. 30. And then this one's pretty easy. This one is just length times width times height. So LWH, length, width, height. So 5 times 1 times 6. This one is also 30. cubic units. So these are the same. Cool. Alright, let's go to number 5 here. So what they are saying is that the height is 5, height is 5, the bases are both 25, 5 times 5 is 25. So the bases are the same, the height's the same, these are the same. Alright, number 6, this one's really easy. Your visual, spatial thinking will come in on this. So yeah, they got the same base, right? Because they said 2. The radius is 2 on these circular bases. So the bases are the same. And the heights are the same. Sick. However, what you're going to start to learn is that when you have an apex, excuse me, geez, voice just cracked. When you have an apex in a cone or a pyramid, the volume ends up being, yeah, it's base times height, but then you have to divide by 3 for a cone. This one is just volume equals base times height. So the cone's going to have 1/3 the volume of this cylinder. It's base times height divided by 3 versus base times height. So these are different. Cool. Now another way you could look at this, like imagine to make a cylinder we have to come up, right? You can start seeing this space right here, which we're going to do coming up. But we're going to do it with a pyramid instead of a cone. But you can see kind of visually why it's divided by 3. But we'll get into that. We're going to prove that in like the next couple of lessons. So anyway, that was lesson 10. Let's see if there's anything else I want to talk about. Oh yeah, the Warriors. This would be nice snapshots we can look back on later. Okay, so here's the record of the Warriors. They are in the 10 seed right now. So, when I was raised, when I was a kid, it was just the top 8 made the playoffs, but the Warriors are in the 10 seed right now. There's something called the play-in tournament, so you're basically in if you're in the top 10, but you have to win. If they stay here, they're going to have to play the Kings for a winner-take-all spot in the playoffs. You want to get in the top 10 to make these last 4 teams make the play-in tournament. So hopefully they'll get it together. Jonathan Kuminga is coming up. Draymond's an important piece for the Warriors, and he's back, so that's good. But anyway, Cavalieri's principle says that if any 2 solids are cut into cross-sections by parallel planes, and the corresponding cross-sections at all heights have equal areas, remember the quarter, then the solids have the same volume. In this image, all measurements are in centimeters. The oblique cylinder and the right prism have equal volumes because they have the same height, 4 and 4, and their cross sections at all heights have the same area of 6 square centimeters. Meaning this has to be 2. These 2 pyramids also have equal volumes. Their bases are congruent. So 5 by 5, 5 by 5. Right? And they have the same height of 7. So shifting a solid from right to oblique does not change its volume. All right, that was lesson 10. The cool down's really tricky but fun. Steph, he doesn't win 4 championships if he's not doing all the gritty work of shooting and practicing and learning. And they used to say back in Jordan's day that the practices were harder than the games. That's how competitive they were. But anyway, Steph doesn't have to rise to the occasion. He just falls back on his training. So make sure you do the practice problems at the end of every lesson. End of every lesson, do the practice problems. If you're not doing the practice problems, you might as well not show up to class. Because if you're missing this whole middle piece, the concepts don't stick. Like, you learn them a little bit in class, they really solidify once you do the practice problems. That way, when you get to test day, like the NBA finals, you just have to fall back on your training. So Steph's a great example. We're lucky to have him. Participation MVP is me. Just kidding. Keep raising those hands. This is a really cool problem. You have to draw 2 solids that are not identical but have the same volume. Check the Unit 5 Quiz 4 video, which is coming up. And just keep focusing, keep grinding, keep hustling. And then you got to execute on the tests. So that was lesson 10. I'll be back soon for the next one.